So this is section 1.8, where we're going to discuss let me focus this, sorry. Okay, we're going to discuss inequalities. I'm going to start by going over linear inequalities quick, because this is something that we've done so many times before in previous classes. So say we want to solve the inequality 6 minus x is greater or equal to 2x plus 9. So we want letters on one side, so we're subtracting the 2x. 6 minus 3x is greater or equal to 9. Subtract the 6, minus 3x is greater or equal to 3. Divide by a negative. Once we divide by a negative, we must flip the sign, as we know from beginning and intermediate algebra. So less or equal to -1, graph it on the number line. And then interval notation, -infinity to -1, and we use bracket because it has the equal sign. If it was less than or greater than, we use parentheses, as we all know. Okay, and if you look at one more from this section, from this part, 28, page 89, 2 times the quantity 7x minus 3 is less or equal to 12x plus 16. Distribute the 2, so you get 14x minus 6 is less or equal to 12x plus 16, minus the 12x, and plus 6. So that's 2x is less or equal to 22. Dividing by 2 will not flip the sign because 2 is positive. Less or equal to 11. Again, this includes 11 and everything to the left. That's why we go to -infinity. So -infinity up to 11, including 11. And we also did, in intermediate algebra, we did compound inequalities. Here's an example, 34, page 189. -3 is less or equal to 3x plus 7. And 3x plus 7. Okay, let me see if I can fix this. Okay, I want to focus this. I'm sorry for the interruption. I want to make sure you're getting the clearest picture possible. So it's less or equal to 3x plus 7, which is less or equal to 1/2. So let's subtract the 7 first. So that's -10 is less or equal to 3x less or equal to -13 over 2. Divide by 3. -10 thirds is less or equal to x is less or equal to -13 over 6. So to graph it, 13 over 6 is -2 and 1/6, and this is -5 and 1/3. So -2 and 1/6, -5 and 1/3, and everything in between, and that's your interval notation. So the linear inequalities, this is the easiest inequalities that we've done and we will do. And now quadratic inequalities. To solve quadratic inequalities, again, since this is a review, I'm not going to write down the steps. I'm going to show you the handout. I'm going to refer you to that, which is on D2L under contact. Look for handouts. See handout for steps. But I'll show you examples. This is what I'm talking about. In order to solve an inequality, quadratic inequality, you want to write it in standard form. You want to solve the equation, the quadratic equation, to find the critical points, and then we put the critical points on the number line to divide it into intervals. Then we pick a test value within each interval. If the test value is a solution, we mark on the whole interval. If the test value is not a solution, the whole interval is not a solution. And then we write the solution set using interval notation. So since it's a review, that's what I'm going to do. So here's an example just to explain all these steps. Page 89. number 42, x squared plus 5x plus 6 is greater than 0. So it's the first thing we want to do is find what we call critical values by setting the equation equals 0 and solve the quadratic equation. Luckily this factors into x plus 3, x plus 2. We set each factor equals 0 to get two critical values. Now these are not solutions. We will use them to get our solutions. -2, -3. So we have an interval from -infinity to -3, and obviously we're going to use parentheses because there is no equal sign. And then the second one from -3 to 2, and then from -2 to infinity. So we have two test values or two critical values. We're going to get three intervals to test. We pick one from each interval. I'm going to pick 0 from interval 3 and test it all the way there. If 0 is a solution, the whole interval is. If 0 is not a solution, the whole interval is not. Put 0 in there. Do we get a true statement? It's true, meaning 3 is a solution. Then they alternate, not a solution, a solution. What do I mean by that? It's false, true, false, or true, false, true. As long as none of the critical value show up an even number of times. Like if you have x equal -3 squared, that's going to give you 2x equal -3. Then they won't alternate. But it's always going to alternate as long as none of the critical values show up an even number of times, like 2 times or 4 times. Okay? So now my solution interval is -infinity to -3 union -2 to infinity. Always write your interval notation. Here's another example. 46, page 89. 46, page 89. We have 5x squared plus 3x is greater or equal to 3x squared plus 2. So let's write it in standard form. Move everything over so we get 2x squared plus 3x minus 2 is greater or equal to 0. I minus 3x squared. I minus 3x squared, and then I minus the 2. And now to get the critical values, we set it equal 0 and we get a quadratic equation which factors into 2x minus 1, x plus 2. So x equals 1/2 is a critical value and -2 is another critical value. Again, we put that on the number line. 1/2, -2. We have an interval from -infinity to -2, -2 to 1/2, 1, 2, and 1/2 to infinity. Again, we only need to test one of them because none of these values show up twice. So we're going to put it right here. So 2 times, we're going to check 0. Is 0 is a solution in the inequality? It's not, because -2 is not greater or equal to 0. So this is false. So it would be true, true. Remember, they alternate. So -infinity to -2 union 1/2 to infinity is my solution set. And it's brackets, sorry, it's greater or equal. I missed that. Okay, so it's brackets. Okay, now rational inequalities. Again, we have a handout for that. Solving rational inequalities. Again, to remind you, when we say rational inequalities in standard form, it's going to be a fraction of polynomials with less than, greater than, less or equal, greater or equal to 0. That's what makes it rational inequality in standard form. And to solve it, again, we have a handout. I strongly recommend you go over that. It's posted. If not, I will make sure it's posted. You want to write the inequality in standard form. This is what I'm talking about. And then the critical values by setting each one of these top and bottom equal 0, and then everything else will be the same. You just have to make sure that no extraneous solutions, okay? Because we have a fraction. So number 60, page 89, 2x plus 6 over x minus 2 is less than 0. So this is p over q. and this is 0. So we're good, we have that form. Then we set each one of these equal 0 to get the critical values. This is -3 and this is 2. So we put those on the number line. So we have the interval from -infinity to -3, and then -3 to 2, and then 2 to infinity, and obviously we should have parentheses. Again, they will alternate as long as none of these show up twice, an even number of times. Put a 0 in there, over 0 minus 2, so 6 over -2, it's true, that's true. It's a solution, so this is a solution, not a solution, not a solution, and that's my solution interval. Let's do one more of these. Uh, 72, page 89. Page 89. 1 over x plus 1 plus 1 over x plus 2 is less or equal to 0. So we need to make this a single fraction. Remember, it has to be p over q is less or equal to 0. So the LCD is x plus 1, x plus 2. So we're going to times this by x plus 2, top and bottom. And this by x plus 1, top and bottom. And then we get x plus 2 times 1, which is x plus 2, and then x plus 1 over x plus 2 times x plus 1, which would be 2x plus 3 if we add like terms, over x plus 2, x plus 1, that's less or equal to 0. Once we have p over q is less or equal to 0, then we do the critical values. It will be -3/2 from top, and then -2, and then -1. And then if we do the intervals, -infinity, 0, so -1, -2, -3 over 2. Remember, we need to have brackets except where the denominator is 0. Because why not? Because you can't have 0 at the bottom, because that would be undefined. And the denominator is 0 for these two values. So we're going to have parentheses at these values, brackets. So when it's less than or greater than, it's parentheses. But when it's less or equal or greater or equal and you have a fraction, you want to exclude the ones where the denominator is 0. You put parentheses because your solution cannot be -2, cannot be 1. Now there's 4 intervals to test. Again, they will alternate because none of these show up even number of times. 0 would be the easiest to use. If I put a 0 in there, 2 times 0 is 0 plus 3, and then 0 plus 2, and then 0 plus 1. Is it less or equal to 0? It's false. It's all positive. So if this is false, this is true, false, true. So -infinity to -2, and then -3/2, including -3/2 to -1. Remember, -2 cannot be a solution, -1 cannot be a solution, because they will make the denominator 0, which means it's undefined. Okay, then we're going to go over absolute value inequalities. Again, we have a handout for that. Solving absolute value inequalities. And here's the handout for that. It shows you all the rules and then a couple of examples. So please go over that. So number 80, page 89. How do we solve absolute value of x plus 1 is greater or equal to 1? First of all, you want to make sure that the absolute value expression is isolated. There is no plus or minus anything next to it. And you can have anything on the right side as long as it's positive. Okay, if it's negative on the right side, then you gotta do it using common sense. So the absolute value is a distance from 0. If the distance from 0 is greater than 1, meaning for any distance from 0 to be greater than 1, that means you're going to have to be greater than 1, or less than negative 1. So absolute value and greater than changes into or. So x plus 1 is greater or equal to 1. It's going to be here, or it's going to be right there, which is less. So you flip this and make it negative. Okay, you drop the absolute value. If you want to have an idea what to do, you drop the absolute value, you get the first one, or then you keep the same side because that's what you have in there, and then you flip the inequality and make that negative. And now you can solve it using compound inequalities. So x is greater or equal to 0 or less or equal to negative 2. You graph it on the number line, greater or equal to 0, less or equal to negative 2. So negative infinity to negative 2 including negative 2, and then 0 to infinity including 0. Here's another example. 3 minus absolute value of x plus 2 is greater or equal to 1. So this is not isolated. We're going to isolate it. So we're going to subtract the 3. We still have a negative here to bring down. We still want to divide by negative 1. That's going to flip that. X plus 2 is less or equal to 2. And now less or equal has to be, basically we're saying we want all real numbers that have a distance less than 2. And less than 2 means you're going to be between negative 2 and 2 to have a distance from 0 to be less than 2. So we drop the absolute value. That gives me this side. And then it's going to be negative 2 less or equal. That's going to give me that. Okay. So less than with absolute value, it's an and. Greater than with absolute value, it's an or. Subtract the 2 to isolate the x. Negative 4, it's less or equal to x, which is less or equal to 0. And on the number line, negative 4 up to 0. And interval notation. And I believe that's it for 1.8, and that's it for chapter 1.